Hello, in this video we are going to take a look at average rate of change for a function between two x values. This is also called the slope of the secant line. So our first function we have, f of x equals negative x squared plus 4x minus 6. And we're going to look at the average rate of change from x equal negative 1 to 3. So what we're going to plug in, we are going to find the slope between the 2 points on the curve where x equals negative 1 and 3. And so just like the slope equation that we use for lines, we want to plug in our y values, which for our function means f of that x value minus f of the other x value. It does not matter which order you plug these in. Normally we plug the bigger number in first and the smaller number in second, but it does not matter provided that the x values you put on the bottom are in the same order. So if you plug in 3 first on the top, then you're going to have 3 first on the bottom. Alright, so f of 3 just means we're going to plug in 3 into our function. So we get negative 3 squared plus 4 times 3 minus 6. All of that is our f of 3. And then we're going to subtract f of negative 1. So we're going to plug in negative 1 for our x. And all of that makes up f of negative 1. You can find those values first and then just plug into the equation. And then in the denominator we have 3 minus a negative 1, or 3 plus 1. Now you've got to remember order of operations on this. This negative out front is not in parentheses, so it is not part of our square. You can think of this as 3 squared and then multiply by a negative. So that's going to be a negative 9 plus 12 minus 6. I believe that simplifies to negative 3. And then we get minus, and then f of negative 1 is going to give us, we'll have a negative 1 squared, so that'll be a positive 1, but then we multiply it by a negative, so we get negative 1 minus 4 minus 6, so that gives us a negative 11. In the denominator, 3 plus 1 is 4. Negative 3 minus a negative 11 is 8 over 4, and that simplifies to 2. And so if you were finding the equation of the secant line, your slope would be 2, or your average rate of change on this interval would be 2. So what that's actually doing for us, if we were to look at the graph, and I'm just going to draw a real rough sketch of this. This is a parabola that opens down, and it has a vertex. Okay, so it's going to look... my artistic ability is not great. But we're going to have a parabola that looks something like this. So if we wanted to look at negative 1 would be about right here, and 3 would be up a little higher. What we're seeing is that the slope of the line that goes through those 2 points where x equals negative 1 and x equals 3, that slope of that line there is equal to 2. Alright, let's do the same thing for the function f of x equals the square root of 2x minus 3. Same exact approach. Here we're looking from x equal 2 to x equals 6. So that's going to be f of 6 minus f of 2 over 6 minus 2. Again, it does not matter which one you plug in first, as long as if you plug in the 6 first, 6 goes first on the bottom, and vice versa. So if we plug in a 6 there, we're going to get the square root of 2 times 6 minus 3. And if we plug in a 2, we get 2 times 2 minus 3. In the denominator, 6 minus 2 is 4. So 2 times 6 is 12, minus 3 is 9, square root of 9 is 3. And then 2 times 2 is 4, minus 3 is 1, square root of 1 is 1. And so on this one we get 3 minus 1 is 2 over 4 simplifies to 1/2. So our average rate of change on that interval is 1/2. And if we were to look at the graph of this one, we would have a similar case. This is going to be shifted to the right, so it's going to look something like that, looking at 2 versus 6. This is 2 and this is 6. The slope of the line that goes through those points is going to be 1/2. All right, I'll see you guys next time.